Well, hello friends. Today I'm going to be taking this merge pull request that Lucas got in, when was this? Earlier this week, 5 days ago, and I'm going to make it work for the Android port of Ladybird. So what this pull request did was it made it so that we're decoding images in a separate process. And this is something that we were already doing in the Serenity port of the browser, but this change here just has a whole bunch of changes to the Ladybird directory here to add our ImageDecoder client and our separate out-of-process ImageDecoder server, which works the same as the other PC servers that are part of Ladybird. But what this one does is I believe you send it a file descriptor over this file descriptor passing local Unix socket. It will decode that socket as that file descriptor as an image and give you back the bitmap data. Okay, that's great. Bunch of code here, but what does it actually do? So if we look at this, here's what the current process architecture of the Ladybird browser looks like at a high level. So we've got the browser Chrome, the UI process. So if we grab my Ladybird window here, that's the thing that creates the window. It has the UI controls, it has menus, whatever else. This is the part of the browser that actually lets you interact with the web content. That process has an IPC connection over a Unix socket. We use stream sockets for reasons I won't go into now to talk to the rendering process. So the rendering process in our browser is called WebContent. In other browsers it might be called renderer or something, I don't actually know. But this is the process that takes in the HTML, it takes in the JavaScript source code, renders the HTML onto a bitmap, it executes JavaScript against the DOM. It's the meat of the browser, essentially. This is where libweb and libjs and libwasm all live. But we don't have everything happening in that renderer process. There's also probably the next most important one is the request server. So when you run Ladybird on Lagom with, what is the option? Oh goodness. With enable Lagom networking, we'll use our native networking stack. If you're on Linux and you don't pass this flag, we'll use Qt for networking, and this picture looks very different. But when we're using the native Serenity servers for networking, we create a request server process. This is where libcrypto and libTLS live. And for every network connection, the connection actually lives inside of this process, and the data from each network request passes through another IPC socket layer from the web content to the request server. Now we have a secondary process that only handles WebSockets. We could probably get away with merging these at some point, but we have a WebSocket process. And then what Lucas added in his pull request was this image decoder process, which I explained earlier. You pass it image data, it decodes it, and passes you back the rendered bitmap for it. And the whole point of splitting out all of these processes, I mean, one of them is that if any of these things that we're doing crash, we don't want to crash the window and have it just close on you and you have no idea what's going on. We want to be able to show like an error page that said, oh, I didn't know what's happening. The other reason is for security, if there's some bug in our, like our WebP decoder, for example, it will only cause a problem inside this untrusted image decoder process. It won't cause a problem with regards to web content or with regards to, the windowing server or the parts of the application that can actually access the file system. So that's the point here. There's also, we have a database, a SQL server that we have, but That's not enabled by default, so I'm not really going to talk about it other than to mention that there is a database process. So this is what is supposed to look like, and if we bring back this window of my Linux version here, and we check what the process tree looks like. You might have seen this earlier as I flashed through it, but if we look here on my terminal, we can see that I ran the Serenity script with enable LAGOM networking. I told it to load the comic here, and we did some magic here to ask CMake to run it for us, but that's beside the point. But here, these processes here is what I just showed in that diagram before, right? We've got the browser Chrome, which is the Ladybird process. That's the window here. We've got our WebContent, which is a child of Ladybird. And then WebContent spawned those 3 helper processes. One for networking, one for just WebSockets part of networking, and one for decoding images. So this is what it looks like on Linux and on macOS and on whatever fun BSD you've built the browser for. But on Android, it looks a little bit different. So on Android, we can't actually just fork random processes and expect everything to work. On iOS, it's even more severe. Like you're straight up not allowed to use multiple processes. But on Android, we can use multiple processes if we use something called a service. So on Android, if we bring up Android Studio here, where are we looking? Where is my, not assets, there we go, my activity. Excuse me, so if we look here, not here, where is it? Where is my Android manifest XML? Here it is. So we look here, we've told Android through this XML file that we have an application. Great, it's an application. It has the main activity, which is our UI process, which runs in the main process that the Android runtime starts up. And then we have a bunch of services down here. So we told it that we have a web content service, a request service, and a WebSockets service. And these all, because I added this process key here, they run in their own processes on the Android device. So how does this work, right? So if we look at the Ladybird main activity, what's happening here? So, right, so when we initialize this guy, we load our layout from that file I looked at earlier, this activity main, which inside all of this gunk at some point has a web view. Okay, so inside this web view, here is, yeah. So since this doesn't actually build right now, I don't have the Android simulator to look at here. But essentially, the app just has a URL bar at the top. That's way too close again. It has a URL bar to the top, and it has just a simple bitmap that we render underneath it. So this is what controls the contents of that bitmap, as shown with this content bitmap. So I mean, this is just the stupidest, simplest view you could create. All the magic happens in the view implementation, where we talk to a bunch of native code, right? So the important thing is that inside the native code, at some point, our C++ decides that it needs to create that web content process, right? So going back to the diagram, we're in here, we're initializing, and we say, okay, I need a web content process. I need to set up this IPC. And what it does is it calls into Java, passes it the IPC descriptors that it initialized already, and we create a service connection and bind an Android service. This will create a new process that runs our service class. And we hold on to this connection to it and whatever else, but at the end of the day, the native code will be holding on to one side of these socket pairs that we created, and the other side will be sent over. Right, Ladybird service connection. Where's this class? So the other side will be sent, right? So when we, how do I explain this? The excuse me. When we bind a service, it starts our service class, and we attach this service connection to it, essentially. When that service process has been initialized by the Android runtime, inside the view process, this onServiceConnected gets called, and we send it two messages, right? We send two messages over the Android communication stuff. One of them is, here's where the resources are. Talk about that at another time. We're not doing that right. And the other one is, here's your sockets, right? And so for all of these services, WebSocket, request server, WebContent, I implemented them in a generic way so that they all use this same service connection where we pass them the path and we pass them these two sockets, and we pass those as file descriptors across to the other process. And this works essentially the same as it does in Linux and macOS, though in that case we fork a process and inherit the file descriptors, whereas in this case we're explicitly telling Android, give us a new process and we're going to send it the file descriptors. Okay, so inside the Ladybird service, I have this base class where they all do the same thing, like I said. And when we get a message, right, if we're getting the resource route, we do one thing. If we're getting our sockets, we do something else. Otherwise, we complain and pass it up to the handler. But essentially, when we pass the resource route, we initialize our native code, and when we get the sockets, we create a new thread to handle those sockets. And this is all handled in the C++ side of things inside this service base, right? So when we initialize a native code, we set up some stuff. It's not particularly interesting. We set the Serenity resource route global variable. We tell the ACK library how to log things, and that's that. And we save off a pointer to the global Java VM. But when we create a new thread, we're creating a Java thread, and we're running our native code in here, this service main. So for each of these services, the WebContent service, here it has its service main. The request server here has its service main. And the, where's the last one? WebSocket service here also has its service main. And I mean, yeah, this is really all we have to do. So if we, all we have to do, right? So the way that, what I want to do today is take this pattern and apply it to that new process that we need to create. And if you've been looking here in my debug log here, I also need to make sure to link lib ImageDecoder client into the WebContent process. Right. So if we look back at this base class, it knows how to do a native thread loop. It knows how to execute a thread, whatever else. And the only goodies that are in these derived classes is what's the name of the service, telling it that we don't have any service-specific messages. Maybe I should delete that at some point, but because I didn't do anything in any of them. But the other thing it does is it loads a native library, a shared library, for the specific service we have. So the WebSocket one, the only things that are different are WebSocket service, WebSocket, the request server service, same thing, and the, where's the last one? WebSocket, WebContent service, same thing. Now, the WebContent service is a little bit special because, like I mentioned back in our diagram, the WebContent process itself spawns new services. Right? So, not this, Android Studio. In order for that to happen, we have to duplicate that pattern we had in the WebView implementation that spawned the initial WebContent service, which creates a service connection, gives it the file descriptors, calls bind service, etc. We need to do that from WebContent. So to bind request server, we create a service connection for it, and we bind the request server service class. Same thing with WebSocket. We create our service connection with our file descriptors, and we bind the WebSocket service class. So this is really going to be mostly copy and paste, but I also got the chance here to explain how this all works. So where do we want to start? I think the best place to start here is with a new Kotlin class. So this is going to be ImageDecoder service. Yes. Yes, yes, added to Git. Okay, if we go back to WebContent, no, not WebContent service, the simple ones. This one, request server service. Oops. I didn't actually need that, but that's fine. Okay. So in here, just copy pasta, all this good stuff, including the copyright header. This is ImageDecoder service. And we need to somehow come up with an ImageDecoder library. So we'll handle that in the CMake a little bit later. So this is all we need for the service. It's very simple. And then over here in C++, not class, just a file. All right, we need ImageDecoder service. What did I call these? Oh, just housekeeping. Okay. Yeah. And then we can just copy paste. Well, actually, what do we need here? Yeah, so what we need here is to go into Ladybird source files, which should be here somewhere. These are all generated files. No? Man. Where are the files? Files are here. ImageDecoder. This main file, which was copied from somewhere else, but we're going to copy it again, even though it looks very, very, very similar to the file we were just looking at. And I'm going to yoink this whole thing. I'm going to paste it in here, including the copyright headers, just to be sure. No, I'm not taking a survey. Okay. So this, yeah, that's all that needs. But this is not going to be Serenity main. This is going to be service main. And service main doesn't take main arguments. Service main takes these. All right. And we don't need these at all, because that's handled by the generic, where is it? Ladybird service base already sets the resource root, so we don't need to tell this guy about it at all. Okay, and is this all we need to do? No, we don't want to take over accepted client, right? We want to. Right, we want to create a socket and then do this. And then we should be good to go. Right, because in Serenity and Linux and macOS, we set an environment variable for the IPC system to use. It's like socket takeover. It's designed for use by system server in Serenity, but we don't need to be doing that. We just need this. Just take this away. And this is, how does this look like this? Just, okay. There we go. Isn't that exciting? What on earth is IPC single server? Don't need this. Don't need libmain. I do need Ladybird service base, right? No? Because I don't really need it. Okay. I think that's all I need. Sure. Okay. So that's all set-ish. And then let's get the CMake all happy. Where's my CMake list for this garbage? How was I doing this? Okay, here I create a Ladybird shared library. Great. Let's look at request server. Oh, okay. Yeah, this pattern. Create a shared library, whatever. Change all this. Yeah, okay. So. Create an image decoder shared library. Include the image decoder service and that and utilities. You don't actually need utilities. Well, maybe you do. That's where the, yeah, you need that. Image decoder here. This. Wait, what were we doing? Right, this uses main.cpp. Got our own main, and by our own main in Android, I mean there is no main, we just get called by Java. Let's see. Image decoder, private image decoder, and then these all get deferred onto that. Is that right? That's right. Okay. So now, on Android, I'm building this shared library image decoder that has my service and the service base, has utilities, it knows how to do this connection from client thing. Otherwise, I'm building a static library and nothing has changed about the build. We don't even install this guy. Yes. And then, what else? Well, let's, oh, right. The WebContent process needs to know how to link this. If we go into WebContent, I did this in a really stupid way. Image decoder. Okay. Not really how that should have gone, but we'll see. This should be that other pattern. Whatever. Can't be bothered. Fix that later. This should be right. Let's see. How far did we get now? Undefined symbol main. What? What are we building here? Bin image decoder. Am I not supposed to do this like this? Yes, no, maybe? Cool. What happened here? Oh, the public suffix. Doesn't that exist? No, it doesn't, because that was merged into libwebview. Oh man, where is that? Ladybird, Android. Yeah. Oh, there goes my build. Do it again, please. Dang, outdated CMake cache. Right, this should take a couple minutes. So while we're doing that, we need to go into WebContent service. Yeah. So we need another one of these guys. So when the WebContent service wants to create a request server client and a WebSocket client, it calls these helper functions. In non-Android, it does something slightly different, but it's morally equivalent. So what are those? So we go into here. I defined these in this header file. This should be ImageDecoder Java. Cool. And then this Java native interface file. And we need to do a couple things here. So we need to create a version of this that calls find image decoder method. Great. And then I need to actually say that I need to grab a Java method called bind image decoder. Alright, and then so that Android Studio doesn't yell at me, I need to, where is this? Oh, I changed views and now everything's gone. In WebContent service, alright, I need to add my function, find image decoder. That's not how you spell that at all. Decoder. This binds with image decoder service.class. Ooh, build worked. It's not going to run until we fix this. Image decoder. They've all got the same fix me. So look, still common. Okay, that looks right. Well, let's see. Where are we at? We've got this. We've got the image decoder service. Okay, we need to go back here. And in the native init here, where we're grabbing the method ID for these, we need to do the same thing here. Bind image decoder. This needs to be bind image decoder. Great. Has the same signature. Okay, now we're all ready to call bind image decoder Java, which will give us an active environment for the current thread, and it will call this method on the service and pass it the two sockets, which is exactly what we wanted. So in where? In WebContent, I need to do the same thing here. So image decoder client is try find image decoder Java. Wait a minute, I have some other methods. Here we go. how does this work in non-Android? Let's see. So in WebContent main, which looks like I'm networking. Wait, where do we? Where do we launch the image decoder? Oh, that's in ImageDecoder client, is it? Who creates this? Image codec plugin. Aha. Oh no, that's not good. Image codec plugin. Do we create one of these for every single image, like a new process? Is this a block? I have so many questions. Okay. Where does this live? Helper process? Launch generic server process. Yeah. Okay. That's not going to work. Does this really launch a new process for every image? That's not great. Okay. Well, we're gonna have to if def this then. That's not ideal. What file is that again? Image codec plugin. Yeah. Not that one. This one. Okay. Oh, if not mclient. Oh, wait a minute. Oh, this guy holds on to a client. One client. Oh, and if it dies, it restarts it. That makes sense. That makes sense. Okay. All right. So you need to know. Yeah, if we're on Android, do something else. Do this. So if we're on Android, you need to know. What do you need to know? You need to know about WebContent service H. That's not how you include things. Oh, this gets interesting because now. Oh, this is static. All right. Well, now it's not static. Congrats, you've been promoted. And null ref putter. Great. All right. Then I just need to yeah, whatever. So we need a bind service here. Yes. Great. I'm just going to plug in WebContent service. Yeah. Helper process. All right. If def Android, otherwise. Come on. This. What are we doing? And client is try launch server process. No. What did I call that method? Bind service. Ooh. You need to know about. Oh no, this is the method. Okay, great. Bind service image decoder client. Give it bind image decoder client. And then how do you recreate your client? Or do you just give up? Wait. Do you recreate your client? No. Do you recreate your client? Install a plugin. Huh? Okay, I guess it doesn't. I guess if it crashes, your browser is completely useless. We'll have to fix that later. Okay, where was I? This, yes, this looks right. Right, because that's how the other guys call it. Find service, this, right. It's just that that's probably not Ladybird image. No. Where are we? In here. In helper process. Image decoder client. That's the name. Alright. Here. That's your name. Okay. That should work. Because then, when we call this, because we need an image, we don't have a client. Okay, let's bind a client. We're going to go into... Where'd my file go? No, I wanted that file. WebContent service. Here. Okay. Well, I copy pasted this already. We don't need this. Right. When it needs it, it's going to call into that bind service guy, which will, just right here, which creates our socket pair, creates one for the UI thread, one for the server, creates another one for the FD passing socket, calls that Java method, creates our local sockets here in the web content process. Well, not UI thread, I guess, because it's whatever. This process is thread. Excuse me. And let's see. And we set that to blocking, and we create a new client of that type and give it our socket. So this is all following the same patterns. And the fact that we're doing this in a different... We had to slap some if-defs into main Ladybird stuff is kind of unfortunate. So this doesn't actually happen here, but it happens in the same way. So with all that said, so I think if I just run this, is it going to build? I don't think it will. I think we're going to be able to see that this doesn't work. It's going to try to like launch a process and it's not going to work at all. Ooh, wait, that means I need to... Wait, am I including ImageDecoder plugin in the right place? Image... Yes. Yes, we are. Alright, so if we do this... Wow, it instantly crashed. Nice. Ladybird. Oh, great. Really? Oh, because we changed... Wait. Why? What? Where's my process? Set... Oh, because... Is it that? Add library Ladybird. Oh. Alright, well, whatever. We can fix that. So if we go to the Ladybird activity, where this library is now called Ladybird with capital L. Whatever. Okay, well, now we don't get to see the before and after, but, you know, this will definitely work first time, right? No, it won't. What happened? Oh, crap. Wait, you should totally know about that file. Oh, no, you won't. You won't know about that file because the path is bad. Okay, let's... Ladybird, Android, source, CPP. Right, is that the path? No. Dang it. Where's my project view? Source main. Perfect. Alright, now build it again. Where's my build view? Oh, baby. Here we go. Use of... Yeah, that's the wrong name. Let's go. Still no. What do we got? Oh. All right then. Let's just pretend that always works. Static declaration. Really? Oh, right. This isn't static anymore. Come on. No? Oh, I need to instantiate that. Just copy paste that whole thing. This is so messy. Here. Put that function here in this file, please. There we go. And now I need to include that. Lib what? ImageDecoder client. Cool. And format this. Really? You're okay with that being there? Whatever. Build. Please. There we go. Let's see. Run it. Huh? Crashed. Alright. What do we got? Oh, great. Hold on. So we can get some nice back traces. We want to go into, not here, here? Min SDK 33. That will give us backtrace. Okay. And let's build the whole thing again. Oh, wait, I need to sync this. Gosh dang it. Right, because if we go to, not backtrace, if we go to assertion CPP, you can see that blah, blah, blah. Okay. In here, if we're on Android and our API level is at least 33, we're going to use exec info, and if that's defined, we're going to grab this exec info header. Great. What does that get us? Well, it means that, come on, when we have a verification failure, if this is defined after we print the error message, we're going to dump the backtrace. We're going to do that with some gnarly looking code that's grayed out because the IDE doesn't know that I set the Android API version to 33, but it will call backtrace, it'll call backtrace symbols, and it'll print them out to the console. All right. This looks like it's going to take a hot minute, so what else? Seems like I probably queued up this this IDE sync in the background. Yeah, this should work. I'll be looking on units. What do we got? So oh, right, because it did like get init for all these things. Got that change. Ew. What did it? Sea Lion, or not Sea Lion. Android Studio screwed with my file here. I'm not supposed to do that. I'm supposed to use my Clang tidy settings, or Clang format settings. Now I gotta fix this dang thing. What else did it screw up? It screwed up this. It screwed up this. It screwed up this. It screwed up this. What else did it screw up? It screwed up. No, that's correct. It screwed up this. Ew. Probably could have done this in like 600 better ways, but I'm just gonna run Clang format on it afterwards anyway. Ugh. All these deprecated strings we need to get rid of. Not insert. Okay. Still running. Oh, you already built for ARM, now we gotta build for x86. Great. Ladybird, Android, main. No? Source, main. CPP, WebContent. There we go. Now everything is pretty. This should have, yeah, moved that up. Great. Are we done? What are we building? Hello? We're still building. Nope. I think we're done. Yeah, we're done. Okay. And yeah, in sync, please. Great. Yeah, shut up. I don't need this. Don't need that either. Okay. Run. Run and crash. Okay. What happened? S default font. Really? Resource / fonts. Oh no. Ah. Okay. Right, that's easy actually. Hold on. Where? Here? Yeah, after this. Let's see. Where did I do this? I did this in utils.cpp, right? In the process of changing the way that we load resources. So in a future commit, this should, so here we say that, okay, the way you get all your resources when you use core resource, which is a new class I made last week or so, is you load them from this file implementation at resource root plus res, which, you know, it works, but it's kind of awkward. Still need to convert all the resource loading in the system to use this core resource file instead of just blindly loading files anyway. But at some point, yeah, here we go. Oosh. Perfect. This should eventually say, hey, use a resource implementation Android or APK or whatever that will then go to the asset manager and do things properly instead of the janky implementation I have now, which is we just archive up all the resources, have that be our asset bundle, and then there's this transfer. Yeah, like we create this asset bundle. It's terrible, but I have this transfer assets file copied from Stack Overflow, which like grabs the assets, looks for the tar file, and then like extracts them. Where do we extract them? I don't know. It doesn't matter. I think it's in Ladybird activity, JNI activity, or something, whatever. But we extract that onto the local storage of the files, or the local storage for the app, which is, you know, that's on your SD card. We don't need to be doing that because it's in the APK, in the assets. So eventually we'll not do this. So that means I need to make sure I add a fixme. Not pound. Fixme. Use a custom Android version. This is asset manager to load files. Great. Okay. Now, build it again. Let's go. Don't got all day. I do have all day to write correct code. Helps if I include the header file. Let's go. And run. Huh? Huh? Oh, we're not loading images. Dang it. Alright, what happened? What? You can't even load the proper cert. Okay. Did we even create the service? No, because I didn't install the plugin. Right. How do we do this? So many steps. I thought this would be easy. Where are we? WebContent. ImageDecoder plugin. This. Did I do that? I swear I did that. I need to be putting some debuggings in here. I did do that. Hold the phone. What happened? Okay, we created the web content, got our sockets, whatever all this garbage is. Created a WebSocket service, created a request service, loaded some junk, tried to load it again. We loaded this, loaded the PNG. So why didn't we try to decode it? Hello? What happened? Where's my source files? Which file? This one. Make this nice and loud. Oops. What happened? Come on. Oh, are we done? We're done. Run. Decoding image. Why didn't we do that? Oh! Right. I forgot to add the service to our manifest. Man. Easy peasy. Okay, now it should work. I don't know how many people caught that one. Hopefully not too many. Are we done? I don't believe you. Do it again. Okay. Go. Yeah, there we go. Decode the image using our new process. Nice. All right. I think that's all we needed to do. Let's make some commits. Yeah, don't need this anymore. Let's see. Where are we at? Wow, that's a lot of changes, isn't it? That is, well, no, it's not that many. Okay. What do we got? Are those changes there? Let's see. Let's fix up. What do we got? So that I'm not keeping. Then we need. I can do this one first. Yeah. Android source main. Gosh, I gotta love Java. Okay. No. Files that include a missing local file. Ah, you got me. Not this. This. What? Thanks for the help, Android Studio. Messing me up. Add that file again. Okay. And let's bring over our commit editor, also known as VS Code. And we are going to say this is Ladybird Android setup a core resource implementation and services. Oops, services, and we're going to say that we're going to use the file implementation until we get around to creating one that uses asset manager. Okay, great. What else? Got those changes to WebContent. Well, what else? These changes are. I can do those first, kind of. Those changes go along with it. That change, I can do that change. This change, get rid of that debug line. Goes to the main change. Oh, that's it. Okay. Okay. No, no. No. Yes. No. Yes. Split. Yes, no. And then all of this is part of that. Do that separately. Separately. No. No. Okay. What is this change? This change is Ladybird Android make start service. What was that called? Is it called start service? It's called. Come on. What's it called? Bind service. Yes, go. Let's go. Bind service. Helper. Public. In WebContent service. Great. What else? I had that change to Ladybird activity. This is Ladybird Android. Use new capitalized name for main Ladybird Schlip. Bird Schlip. Okay. And is that everything? Got everything that we split out. ImageDecoder, ImageDecoder, ImageDecoder. Yeah, whatever, I'll merge that in. ImageDecoder. Get rid of my debug line. Great. Where was that? This. Cool. And then it'd be nice if we could do this eagerly. That took a hot minute to decode that image, but progress is progress, right? Right. Oops. Don't want the build.gradle. I didn't need to do that. Okay. What do we got? We've got new service. We are making sure that we can create it. We're stashing our helper. We've got the function to call. Got our new service thing. We are calling it from the right place. We're creating a library instead. Okay. Great. Okay. This is the big one. Ladybird Android. Create a service for ImageDecoder. This follows the pattern for the other services spawned by content. Now the notable quirk about this service is that it's actually spawned by the image codec plugin rather than in main, the non-Android port. As a result, needed to do some if-def surgery to get all the pieces in place. But we can now load images in the Android port again. Where's my smiley face? There's my smiley face. All right. I think that is my last commit here. I had some other fixes here, but seems like a pretty good haul here. If you made it all the end, jeez. Made it all the way to the end. Thanks for watching. Hope to make more of these development videos. And see you around. Bye.